This video will focus on the problem that is above the line here in terms of your equilibrium test. So for every problem on your equilibrium test, as you look through it, you should really be paying attention to the numbers and trying to figure out what the numbers mean. So it says blah, 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 right? We don't care about any of that. We have this number here, 0.00116. One thing I noticed is there's no label on it. There's only one number in this unit with no label on it, and that was my equilibrium constant. So if I do look just a little before that number, I can see with the equilibrium constant of, that means this number is my equilibrium constant. Equilibrium constant is otherwise known as KEQ, equilibrium constant. So my equilibrium constant for this problem is 0.00116. I give you a temperature of Kelvin. We don't care about it. There's no Kelvin in any of our problems. It's just there because K is temperature dependent. I keep reading, I see that I have a concentration number. Big M is concentration. So I have 0.3179 big M. And so it says if I have 0.3179 big M of COF2 and it's allowed to decompose. Allowed to decompose is an action. It's a process. This is not at equilibrium. It is before equilibrium. I can also tell that that number is not equilibrium because the question is, what is the concentration at equilibrium? If I'm going to ask you the question, what's the concentration at equilibrium, I'm not giving it to you. So given the fact that I have a number that's not at equilibrium, and then I ask you for numbers at equilibrium, this is a rice table problem. So a rice table problem happens when I'm given a number with an M that is not at equilibrium. I am given this number not at equilibrium. So that number, that 0.3179, that is my concentration of that COF2 initially. I allow it to decompose. If I'm allowing it to decompose initially, this stuff doesn't exist. So I can put zeros there. My change row always has two pieces of information, the sign and the how much is changing based on the coefficients. So your zeros always have to go up. There's no such thing as a negative amount of stuff. If you take 0 and you subtract something from it, you get a negative amount. Fake. That means my COF2 has to go down in order to produce the others. How much it goes up or down by is the coefficient times x. There's a coefficient of 2, so it's 2x. There's no coefficients in front of CO2 or CF4, so the coefficient is 1, so those are just x's. Equilibrium then is always my initial written down amount plus or minus the change depending on sign. So you can actually go 0 plus x if you want to remind yourself that it is that initial amount plus or minus x. But obviously 0 has no amount of mathematical quantity, so I will leave that 0 off from here on out. If I look back up at my problem, I don't have any other numbers, okay? But in the end, I want to know the concentration at equilibrium. This is where it's at in terms of understanding this problem conceptually. This part of my rice table, E of my rice table, means concentration at equilibrium. If I could solve each of these things that I've written here, if I could solve what this number is and solve what this number is and solve what this number is, I would have the concentrations at equilibrium. The way you go about solving for that when you are given a KEQ is you can use your K expression to solve for X. So it's always product divided by reactant. So these are on top, and then this is on bottom, and we raise it to a power of the coefficient. Now I give you the KEQ because that is the equilibrium constant. It is a constant, not a concentration. So that KEQ equals all those little brackety guys. What do I fill in for the brackety guys? Well, these numbers are the same as this E, right? This E informs that bracket, and that bracket is this E. So the bracket CO2 is that 0 plus X. And that bracket CF is that 0 plus X. That bracket COF2 is that 0.3119 minus 2X. And that still has to be squared because this is squared. That's the setup for this problem in terms of how to now figure out what X is. I now have an algebraic expression that I can actually solve. The trick here for these is that I'll always give you a problem where you don't have to quadratic. You can square root both sides to get yourself an easier algebraic expression to solve. So this now, if I square root, is 0.034058. How many numbers do you write down? I don't know, some. This is the middle of your problem, so you don't really want to sig fig right now. So you kind of want to record a decent chunk from your calculator. Right, so now to rearrange this to solve algebraically, you have this number and you're going to be multiplying it by that 0.319 minus 2x. And that just equals 1x because we square rooted it. Okay, so now if we distribute into that parenthesis, we have 0.0106229 blah, 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 right? Lots of numbers, minus 0.06811175 x, and that still equals this x on the other side. Now I'm going to collect like terms, so I'm going to add those x's onto that side. So 0.0106229 crazy jazz is added to that 1x, so 1.06811175x. Getting x by itself, I'll divide this thing over here, right? Divide it over, and this is getting me my x. X for this problem equals 0.00994547, oh my gosh, numbers. Now, somewhere along the way, you find your calculator gave you a different answer than my calculator. We all know Miss Lee is fallible. I tend to love to make mistakes. Know that in the end, the algebra is the algebra. I'm doing the best I can here, but you get the idea. This is not my answer. Remember, my answer was the solution to this. So now I'm going to come over here and plug x back in to figure out the answer. The answer is actually three numbers. I need the concentration of COF2. I need the concentration of CO2. And I need the concentration of CF4. All of these at equilibrium. CO2 and CF4 are both defined as X. So the concentration of these at equilibrium, if I now round to 3 sig figs, because that looks like kind of what I have, 0.00995. Here's where many people lost points on the test. The unit for concentration is a big M. If you do not have a big M on your concentration, you did not do the problem right down to the very last minute. Okay, make sure you put all the things in when you do your life. Okay, concentration of COF2 is this 0.319 minus 2 times X, which if I do that, I got 0.292. And again, that's a big M. So this is an example problem again of where I give you initial information, ask for equilibrium concentrations. You have to solve for that X to plug it back in to get to your final solution.